So we are going to go over pressure. This is literally so bad. So pressure volume, the pressure volume, it shows a curve. And it shows what's happening in the left ventricle during one heartbeat. So in this ventricle, it looks like a loop, and each part of the loop represents a phase of the cardiac arrest. So it's kind of like that. I don't know if that makes sense. It starts with ventricle filling, where the ventricle fills with blood from the atrium. Pressure is slow, but the volume then increases. Then comes contraction. The ventricle starts to contract. Pressure shoots up. But volume stays the same because all valves are closed. Next is injection. And this is when the pressure is high enough to open the aortic valve and blood leaves the ventricles, so the volume drops. And then there's relaxation. And that's when the ventricle relaxes, pressure drops, but volume stays the same until the cycle starts again. So I want to talk about preload, which is how much blood fills the ventricle before contraction. And then we have after load. That is the pressure So it's how much pressure it's pushing to eject blood. And then we have entropy. And it's the strength of the contraction. Okay, so next we have the baroreceptor reflex. And so this helps our blood pressure stay stable. The pressure sensor is located in the aortic arch. And I forgot. What am I saying? Okay, anyways, when blood pressure rises, these receptors sense the stretch and send signals to the brain, which then tells the heart to slow down and the blood vessels to relax, lowering blood pressure. If blood pressure drops, the opposite happens. The brain tells the heart to beat faster and blood vessels to constrict, raising pressure. It's super fast, like a minute-by-minute adjustment system. And then so this I meant to put that. So MAP is basically the average pressure in the arteries, and it's what keeps blood flowing to organs. It's regulated by cardiac output, which is how much blood the heart pumps, and then total perfume, and how narrow or wide the blood vessels are, and also blood volume. And then we have so there's two main things here. We have the so hydrostatic pressure pushes fluid out of capillaries into tissues, and colloid osmotic pressure mostly from plasma proteins like albumin, I don't know, which pulls fluid back into the capillaries. At the aorta end of the capillary, hydrostatic pressure is stronger, so fluid moves out. This is called filtration, and the venous end hydrostatic pressure drops and osmotic pressure takes over, pulling fluid back in. And then we are going to talk about edema. A good example of this is heart failure. In heart failure, the heart can't pump efficiently, so blood backs up in the veins, increasing hydrostatic pressure. The extra pressure pushes more fluid into the tissue, especially the legs and feet, causing swelling or edema. And so yeah, that's that.